Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 7 from the May-June 2019 paper 4, variant 2, mechanics paper from the Cambridge 9709 syllabus. And this question is about variable acceleration. So here we have particles P and Q, which leave a fixed point at A at the same time and travel in the same straight line. So they're traveling along the same straight line and they're leaving a point A at the same time. The velocity of P after t seconds is given by the equation 6t times t minus 3 meters per second. And the velocity of Q after t seconds is given by 10 minus 2t meters per second. So first of all, we have to sketch on the same axes velocity time graphs for P and Q for t between 0 and 5 seconds. So what I'm going to do first is I'm going to draw my axis for my y-axis and my x-axis, the y-axis being the velocity and the x-axis being the time. All right, now we can see here that we have a quadratic, and it seems like we're going to have a negative velocity there. So I'm going to extend this on the negative side. So that's the velocity and that's the time. And that's the origin. So the velocity is in meters per second and the time is in seconds. Now, we want to sketch the graph of these two on the same axis. So what I'm going to do now is I'm going to look at each of these separately. So let's look at P first. P is basically a quadratic, because if we were to expand this, we get 6t squared minus 18t, which is a quadratic, and it has the type of shape where it has a minimum opens upwards, right? And because the coefficient of the t is positive, t squared is positive. So we've got to draw it between 0 and 5 seconds. So let's see what happens when time is 0. Now, when time is 0, the velocity of P is going to be 0, because you're going to have both of those will be, you'll have 0 times something, it's going to become 0. Okay, so it's going to go through this point when time equals 0. It's going through the origin, and we're going to find where it crosses the t-axis. You know, so we can draw it. No, it's going to go like this. So it's obviously going to go up. So where else does it cross the t-axis? Well, we can find out when v is 0. We have 6t times t minus 3 equals 0, which is a factorized version of this quadratic. So we can then solve it very easily. Either 6t is 0, in which case t is equal to 0, which is this point anyway that we found already, or t minus 3 equals 0, in which case t is equal to 3 seconds. So it's going to cross this axis at 3 seconds. It's going to have a minimum, it's going to go up like this. So exactly halfway between 0 and 3, 1.5, that's where it's going to reach its minimum point, of course. So it's going to look something like this. It's going to turn at that point and go upwards through 3 until we reach 5 seconds. Okay, so at 5 seconds, what's going to happen to it? We can work out what its value will be at 5 seconds. So this is 5 seconds here. Now, what's going to be its value at 5 seconds? Well, when t equals 5, Vp is equal to 6 times 5, which is 30, times 5 minus 3, which is 2, which is 60 meters per second. So at this point, it's reached 60 meters per second after 5 seconds. So that's the curve of Vp. That's the journey of P. Now Q is a straight line, okay, because it's a linear graph, and it has a negative gradient, it's -2. And when time equals 0, so for the velocity of Q, which is 10 minus 2t, we can say when t equals 0, the velocity of Q is equal to 10. So in the time that we're looking at this from the beginning, when time equals 0, it's moving at 10 meters per second. Okay, and what's happening is when time equals 5, okay, which is the end of the journey, it's going to be a straight line. the velocity of q is equal to 10 minus 2 times 5, which is 10 minus 10, which is 0. So this one actually is going to be going like this. Let me just change the color a bit as well. Make it a different color. So this is going to go something like that. It's just a straight line with the negative gradient. So this represents the journey of q. Okay, so there we have drawn on the pair of axes, the same pair of axes, the velocity time graphs for p and q. All right, now that's 3 marks for that part of the question. Now we're going to go on to part 2. It says verify that p and q meet after 5 seconds. So that means they will have the same displacement after 5 seconds. It doesn't mean they will have traveled the same distance, but they will have the same displacement, because just imagine now we're starting at this point A. Now in the beginning we can see that the particle P is moving. If I consider this a positive direction, particle P would be moving in the negative direction because its velocity is negative. In this whole region between 0 and 3, the velocity is negative. So if we take that as positive, the particle P, okay, will be going in this direction. Okay, and at first its speed will be accelerating. It's accelerating, and its speed will be getting greater, but in the opposite direction. But then the acceleration becomes 0, and it starts to become negative. It starts to decelerate until it comes to rest at 3 seconds. So at 3 seconds, it comes to rest. And then what happens is after 3 seconds, it's accelerating but changing direction. Okay, because it goes now in the positive, the velocity now becomes positive. So now it's going in this direction. And it's going to end up after 5 seconds, let's say over there. Now, if we consider the journey of A, okay, if we consider the journey of A, then what? Oh, sorry. Oh, this is for Q. Now for P, sorry. If we consider the journey of Q, now this starts going in the positive direction, but it's like slowing down until it comes to rest. But we got to show that t equals 5. Okay, that they have the same position. They're at the same position at 5 seconds. Okay, so we have, this is the journey for P, sorry. Let me just make that better. This is for P, and this one here is for Q. Okay, so basically at the end of 5 seconds, they will be the same distance away from A. So we're not considering the distance that A has, that P has traveled. We're considering its displacement. And when we're considering also the same thing, the displacement of Q. Now for Q, the displacement and the distance are the same. Okay, it will be the area under this triangle. Okay, that will be the displacement for Q. But for P, the displacement will be the area between 0 and 5 between the curve and the axis. And we don't split it into 2 sections because I'm not looking for the distance traveled. I'm looking for the displacement. I'm not looking for the total distance it's traveled. I'm looking for this displacement has to be the same from A. It has to be the same, in the same position in relation to A as Q is at that same time. So therefore, let's first work out the distance that Q has traveled. We can use the fact that we have a triangle. Okay, we could have done it using integration, but it's just a triangular shape, so there's no need to go to those lengths. We could have integrated and got it, that's fine, but I'm going to just draw this triangle. Okay, so we have a triangle. Okay, the area under the triangle is the distance traveled, okay, by by Q. This is for Q. Okay, so the distance or the displacement, we can say, let's call it SQ. the displacement of q is going to be a half times the base. Now the base is 5 seconds and the velocity was 10 at the beginning, so it's going to be a half times 10 times 5, which is going to give us 5 times 5, which is 25, okay, meters. Okay, that's the distance, the displacement of q after 5 seconds. This is when time equals 5. Now, as for p, we have to integrate between 0 and 5 the expression which I'm going to write in its expanded form, so that's easy to integrate. So it's 6t squared minus 18t with respect to t. So we have to integrate that between 0 and 5 without considering the fact that it touches the x-axis and there's a negative and positive area. We want them to be different areas. We want to know what the difference between those areas is for us to know the displacement of p. That's what we're looking for. Not looking for the distance it's traveled, looking for its displacement. So we can say the displacement of p is going to be given by, now let's integrate this. So you have 6t cubed over 3, which is going to give me 2t cubed, minus 18t squared over 2, which is 9t squared. And that's to be integrated. So we have the limits of 0 and 5. Now this should give me 25. If it gives me 25, we know we're on the right tracks. So because we have to show this, we have to be very careful to show our steps here. So 2 times 25 cubed, 2 times 5 cubed, 2 times 5 cubed, minus 9 times 5 squared. And that should give us 25, hopefully. Let's see, we have 2 times 125. In fact, we can do this. 2 times 125 is 250, minus 9 times 25. Okay, so you have 9 times 25, which is 225. So we can see that 250 minus 225 is going to give us 25 meters. So the displacement of p when time equals 5 is 25 meters. So we can say as the displacement of p equals the displacement of q when at t equals 5, therefore, okay, they meet after 5 seconds because they're at the same place at the same time. Okay, so that's the proof for that part 2. Okay, and there we have that answer. Now we're going to go on to the next question. Now for part 3. Find the greatest distance between P and Q for the time between 0 and 5 seconds. Now we know the expressions for the velocity of P and the velocity of Q already. We also know that if we just recap on the situation, we had the point A where they both started from. If we consider P and we take this direction as positive, then P started out by moving in this direction. Okay, so it started out moving in this direction, and 3 seconds into its motion, so this is when time equals 0. When time equals 3 seconds, okay, it changed direction and it started to go in this direction, okay, until at 5 seconds it had its displacement, not its distance, but its displacement from A, okay, was 25 meters. Okay, that was P. As for Q, it started off at A and it basically just went in this direction. It just went, and it went 25 meters in one direction. It started off with a speed of 60 meters per second and it ended up with a speed of 0 meters per second. This started off with a speed of 0 meters per second. Okay, so this started off, with a speed of 10 meters per second and ended up with a speed of 0 meters per second after 5 seconds. So this is also 25 meters, the same distance, and this is at time equals 5. This is at time equals 0. So those are the two situations we have here for these two, for P and Q. This describing what happened with P, and this describing what happened with Q. All right, so now we've got to find the greatest distance between them during that 5 seconds. Now, basically what they're asking us, I mean, it says the word distance, okay, but the greatest distance between them would be basically the magnitude of their displacement. The magnitude of the displacement. We're going to find the greatest magnitude of displacement between these two. We want to find that, that displacement when they're furthest apart from each other. That's what we need to find in this question. We need to find, that's the thing that we're trying to we're looking for here, right? So in order for us to be able to find the greatest displacement between them, okay, we need to know the equations in terms of the displacement. Okay, so I need to find what the displacement of P is, and I need to find what the displacement of Q is. Okay, so I need to find the displacement of P and an expression for displacement of Q, and then I can try to work out the difference between the displacements and then try to figure out how to find the maximum distance between them. Okay, so that's what we have to do here. So now, the displacement of P is going to be found if we integrate the expression for P, which is 6t squared minus 18t with respect to t, which we actually already did there. Okay, but I want to find this as you can say, I want to find what SP is in terms of t. Now I can use any of these values. I know that when t equals 0, s equals 0. And when t equals 5, s equals 25. So I can say that I want to find s when t, in terms of t, I know when s is 0, t is 0. I could use those points, that's fine, and that will give me the answer. I could even use when s is 5, t is 5. Okay, and I should get exactly the same answer. Sorry, s is 25. When s is 25, t is 5. Okay, when s is 25, t is 5. And I should end up with exactly the same expression either way. Okay, because those are pairs of values where s is going to be, that's s when t is 0, that's s when t is 5. All right, so now I need to now integrate this expression. So this will give me, if I put sp and 0 in here, it will be sp straight away, equals. Now, when I integrate this, we already did it in the last question, but just add 1 to the power divided by the new power, so 6t cubed over 3, which is 2t cubed, minus 18t squared over 2, which is 9t squared. We have our limits of t and 0, so therefore we can say sp is equal to 2t cubed minus 9t squared minus 0. So that's going to be an expression for the displacement of P. And if we do the same thing for Q, exactly the same thing for Q, we have SQ, okay, and I know that I'm trying to find what SQ is. I know that when S is 0, and then I'm going to do my integral here, I've got 10t minus 2, sorry, 10 minus 2t, 10 minus 2t with respect to t. I know that when t is 0, okay, I want to find s in terms of t, and I know when the displacement is 0, the time is 0, okay? So I can do exactly the same thing here. I can integrate this, so SQ, okay, so this will just give me SQ, by the way, just SQ. SQ is equal to, now I can integrate this, that's going to be, the 10 will gain a t, the 2t will become 2t squared over 2, which is minus t squared, and I have my limits of t and 0, so now SQ is going to be 10t squared minus t squared and then minus 0. So that's an expression for the displacement of P, and that's an expression for the displacement of Q. Basically what's happened is the plus C was 0, both cases. Now, the distance between them is going to be the magnitude of their displacement. So you can say SP minus SQ. Okay, so let's work out what SP minus SQ is as an expression. Now SP minus SQ is 2t cubed minus 9t squared, take away 10t squared, 10t, sorry, that's a mistake there, that should be 10t. Let me just correct that. I wrote that down wrong. So that's 10t minus t squared. So that's going to be minus 10t minus t squared. So that's going to give me 2t cubed. You've got minus 9t squared plus 1t squared, which is minus 8t squared, and minus 10t. So that is an expression for the displacement between P and Q. Let me call that the displacement between P and Q, SPQ. Okay, so that's 2t cubed minus 8t squared minus 10t. I want to find the maximum value of the displacement between P and Q. I need to find SP max, you could say. Now, to find the maximum value of a function, you need to find the turning points. You need to differentiate. So what I'm going to do is I'm going to find dSPQ over dt, and that will help me find, and I know that this must be 0 at the maximum. This must be 0 at the maximum or the minimum. But the maximum is going to be equal to 0. So let's find what this is. So we're going to integrate this with respect to t. Now that's going to give me 8t squared minus 16t. Sorry, not 8. What's going on with me today? That's 6t squared. 3 2's are 6. So multiply by the power, take 1 from the power. Multiply the power, take 1 from the power. And the minus 10t will leave you minus 10. So at the maximum, we know that this is true. So we can say that 6t squared minus 16t minus 10 equals 0. We need to solve this equation, which we can simplify it by writing it as 3t squared minus 8t minus 5 equals 0. So this is the equation we need to solve. Continuing on the next page. So I need to solve this equation to find the values of t when the displacement between them is a maximum. So this, if we try to factorize it, it won't factorize because we can't find two numbers that multiply to give you negative 15 and have a sum of negative 8. I mean, to get 15, you need 3 and 5, but the signs have to be opposite. That won't give you negative 8 when you add them together. So there's no way to factorize this, because the only way is getting 15. 15 times 1, 3 times 5. So it won't work. So we have to use the formula. Now, we can't just put our calculator answer. We can't just use the equation function in the calculator to write the answer down. You will lose marks for that. Okay, the states very clearly that you must show the steps for this. So you have to use the formula or completing the square. In the case that you can't factorize, so we're going to use the formula here. It's probably easier for this type of question. Now, we know the quadratic formula is given by x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, you don't have to quote the formula, but you have to know how to use it. So in this case, that x is going to be t. And a is the coefficient of the squared term, so a is going to be 3. B is the coefficient of the non-squared term, like the minus the t, so it's going to be minus 8, and c is the constant, which is minus 5. It must say equals 0 like it does, and then we can proceed. So you have minus b, so it's minus 8, so it's going to be minus 8, so be careful about that, plus or minus the square root of b squared, which is minus 8 in brackets squared, minus 4 times 3 times minus 5, all over 2 times a, which is 3. It's very important that you put these numbers in the right place. Those will be your method marks. If you did that, you'll get the method marks with this question if you put the numbers in the right place, even if you did not quote the formula. So now what we're going to do is we're going to stick this in our calculator. So we have minus 8, which is 8, plus, we'll use the plus first, square root of minus 8 all squared, which is going to give you 64 positive, because you're squaring a negative, minus 4 times 3 times minus 5 over 2 times 3, which is 6. And that gives us 4 plus root 31 over 3. So 4 plus root 31 over 3. And the other value will be 4 minus root 31 over 3, which you get if you put, instead of this, the minus sign. Okay? So Now, one of these is positive, the other one is negative. I think this is negative. If we work out what this is, it's going to give us a negative value, right? So this is, of course, rejected. So this is our, not our answer, but that's what we're going to use to find out our answer. We have to find, as the question said, if we go back to the actual question, it says find the greatest distance between P and Q. So we have to find the greatest distance between P and Q, which is basically the magnitude of their displacement. Okay, so we've got to find the magnitude of this. So you have 2 times, now we've got T as this value over here, 2 times 4 plus root 31 over 3 cubed minus 8 times 4 plus root 31 over 3 squared minus 10 times 4 plus root 31 over 3. Okay, and that will give us our answer. So our answer is going to be the magnitude of that. So if I put this in my calculator, so let's go back to this answer here. Okay, so this is now my answer. Okay, so I'm going to now put 2 times the answer cubed minus 8 times the answer squared minus 10 times the last answer, and that gives my answer as minus 48. So it's the magnitude of negative 48.385 carries on. Okay, so the magnitude of that is going to be 48.4 meters. So that's the maximum distance between P and Q, 48.4 meters. Okay, so that's what we have to, that's how we deal with this question here, in terms of finding the maximum distance between them. All right, so that concludes this question number 7, which is the last question in this particular chapter, or in this particular, paper. Other questions from this paper can be found in the playlist that will appear in this region over here. Other questions from variable acceleration of P1 at Cambridge, not P1, Mechanics 1 Cambridge can be found in the playlist over here. This is for 9709 syllabus. And you can subscribe to my channel by clicking on this link, and you can watch a video here. It will be linked at the end, which tells you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.